Hello, I'm David. This is revision seminar for Maths 1M in semester 2, 2022, but actually we're going to talk about study problem solving exam skills first, and so that should apply to any course. So just bear with me, it won't just be for Maths 1M, so if you're watching this in the future because you found it on another course's webpage, it's because I thought it was useful for you and that's why I put it there. So have a look and hopefully it'll be useful to you. Okay. Right. Okay, cool. These will be on the website too, these notes. Okay. Well, the thing that's on our mount at the moment is exams, and I might sort of start there, but it's going to come back to these later. So, I guess the first thing to recognise with the exams is that they are an unnatural thing. Like they are not a natural state to be in, and so you have to learn how to do them because they're not just things that humans can do, because they're unnatural. And so the situation itself has to be coped with as well as the learning that you're trying to display there. So I guess just recognizing that is important to make sure that you cut yourself some slack, that it's not natural, and also recognizing that you're going to have to deal with the examness of it as well as the top content. So the first piece of advice about exams that I want to say is if you know the content, then the exam will be easier. And I know that sounds silly, but a lot of people ask, how do I prepare for the exam? It's like, well, you need to know the content. And spending a lot of time stressing about what things in the course are going to be in the exam is less important than just knowing the things. So everything that they taught in Maths 1M, the people who taught this course think is important. And even though some of it might not appear in the exam, it's there because it helps you understand the later things that are in the exam. So when I say know the content, it means try your best to understand it. And by understand, we mean how does it fit together? So the sensation of understanding happens when ideas are connected to each other in your brain. So you won't feel like you understand something unless they're connected. Like this is a picture of things that you might know in the structure of your brain. And this will not feel like you understand things. Just remembering random stuff, you won't feel like you understand. But knowing how this is connected to this, and this is connected to this, and this is connected to this, and these are things that are all connected to each other, that's when you will start to feel like you understand stuff, because they're connected. And so you'll go, I know this because it's related to this thing, and that helps me understand them both. But this thing here that's not connected to anything yet, you'll feel like you understand that less than this thing here that's connected to lots of other things. And so understanding comes from connecting things together. And it also comes from knowing where the edges of things are. So I'll talk about that as well. I'm just making this up as I go along today. I didn't prepare this, so bear with me. So you don't feel like you understand this very well. And this sensation of understanding, which happens when things are connected to each other, it doesn't have to be connected to other ideas, though that helps. It can be connected to experiences and emotions and things that you know, like other things that don't seem like knowledge, like films you've seen or life experiences you've had. So you can understand things because they are like other things you know. You can do analogies and pictures and those sorts of things. So it works best if they're connected, the ideas are connected to each other, but don't just try and connect it to other ideas. So this isn't just for understanding things, it's also for remembering things. If you want to remember this thing here, then you may first remember this thing, and because you know how they're connected, you can get to this thing here. And so you mentioned trig identities earlier. There's like several trig identities, but there's the fundamental trig identity, and cos squared plus sine squared is 1, and most of the others come from there. And so knowing how they're all connected to each other means that you don't have to put so much effort into remembering them all, you can only remember one of them and you can get to the others from there. Which is how most people remember their times tables. Like their multiplication facts, most people don't remember their 7 times multiplication facts, but they figure them out from the 6 and the 8s. And so I don't know what 7 times 8 is, but I do know what 7 times 7 is, and I can figure it out from there. And so knowing how things are connected means that you don't have to remember everything either. So really, one of the best strategies you can have for succeeding in an exam is all the way through the course, but even if it's now, it's not too late, is to try and make things connected to each other. And every time you look at a page of the notes, you can go a little bit before and a little bit after and see what it's connected to. And it mentions a concept, and you say, oh, that was back in week 1, I can talk about that. And you can say, which trig identities did they use? The ones that they use most often are the ones that you need to know. They're connected to things. So that's my first big piece of advice, is to know how things fit together. Cool. My second piece of advice is specifically about exams, and it's about being fast. Exams are horrible because you may be able to do something in an hour, but the exam only gives you 10 minutes to do it. And while most exams are written in such a way that they don't take you an hour to do, they are also written in such a way that they assume that you remember all the things you need or how to get them quickly. So many maths exams have the ability to take a sheet of notes with you. Don't know if that's true in this one. And a sheet of notes is a lot less helpful than you think it is. It's there to help you find things that should be in your brain already, that you're having trouble remembering. But it's just because you don't know the details, you know the general idea, or you know where it is on the cheat sheet so you can look at it. But if you're reading your cheat sheet to find information, then you're doing it wrong. So we'll get back to that in a minute too. So there are 2 aspects to being fast. Aspect 1 to being fast is knowing stuff. If an exam question mentions a word like projection, you have to know what that means. And so you have to know the facts, i.e. remember them, without having to think very hard, because then you'll be faster. If you have to stop for 2 minutes to try and remember things or look them up, you'll slow down, you'll be slower. And so knowing the facts is about remembering, and remembering is about practicing remembering. So while it's awesome to have everything connected to each other, which makes it easier to remember stuff, the only way you can be good at anything is to practice the thing. So to remember, you have to practice remembering. So if you're studying, one of the worst things you can do is just look at your notes. What you should do first is don't look at your notes and try to remember what's in them, and then look at your notes. Because then you're looking at your notes will be telling your brain which bits you were good at remembering or not, and then you'll be able to go, oh, I should remember those things that I wasn't that good at remembering. The act of trying to remember is the thing that makes you good at remembering. So we fool ourselves into thinking that recognizing something is the same as remembering it, and it's not. So, and what you don't want to do is to practice recognizing. So you look at your notes and you go, oh yeah, that's the fundamental trig identity. Cool, I recognize that. That's a whole different thing from saying, what's the fundamental trig identity, and attempting to write it down. That's the first is recognizing, the second is remembering, and they are different things. So my recommendation is to literally give yourself time every day to sit and remember things. And every time you go into a new topic that you're wanting to study, say, oh, I want to study trig functions, you can sit and try and remember what you can remember about it. And any remembering is good remembering. Remember what it felt like to do the assignment questions. Remember one of the Mobius questions. Remember what the lecturer said. Remember topics, whatever. Just write down whatever you can remember, and then when you look, you'll reinforce the things that you did remember correctly, and you'll correct the things that you remembered incorrectly, and that will make you better at remembering. And I know that maths isn't about memory, but you can't do maths on something that you don't remember. If you've got a formula, then you can do algebra, but if you don't have a formula at all, you've got nothing. So, cool. And the second thing that makes you fast is literally practicing writing quickly. So one of the problems that happens in life is that an exam is one of the only times in life where you are required to write at a pace, like physically write with your actual hand at a pace that needs to fill in all of the details. So when I've said this to people, they've looked at me and gone, this seems stupid. So it's not stupid at all. I had a student at least once a year who says, my hand is sore. I cannot write at that speed for that long. And it's literally a sport thing. You have to teach the muscles in your hand and arm to be able to do that thing. Luckily, this thing is thing you can do to practice writing quickly. You can sit down for 5 minutes and write as many things as you can. And so you can do both at the same time. But also, practicing writing fast, it doesn't have to be maths. It can be anything. So if you're the sort of person who likes to write a journal, then that works too. A really good thing to do at the end of every day when you're studying is to write down all the things that you did today. You don't have to remember everything at the beginning, you can remember at the end as well. And just, I'm just going to write everything I can think of. And even if it's just repeating something over and over so that you get it into your brain, practicing that writing fast so that it is clear for someone to read, writing fast and clearly, is not the worst thing to do. Yeah. And so the last thing about being fast is the thing that you said, which was, how do you decide what to do quickly? Because you said that on a lot of the assignments, you look at it, you're a bit stuck, you talk to someone, and then you go, oh, okay, and I've got an idea, and then off you go. And in the exam, you can't do the talking to someone step, and you also can't You also just have to trust entirely on your own power to make that decision. And so somehow you have to practice making decisions quickly. And if you want to get good at anything, you have to practice. So one of the things that you can do with old tutorial questions, and they only give you one practice exam. They don't give past exams anymore, I believe. Sometimes they give 2 practice exams. But if you can actually look at the questions and practice the act of deciding and not finishing the whole problem yet. So in an exam, one of the best things to do during the beginning of exam time, some exams give you reading time, some exams don't. But one of the first things to do is to read the whole exam and try to make a quick decision about what you're going to do first for each of them. Without actually making a plan, just decide what to do first. So you said, is it good to make a plan? It's like, probably not, because the writing of a plan is a waste of everybody's time, because you should be writing the things that you're supposed to get marked on. But making a decision of what you think you're going to do first is probably a good thing. So practice deciding what to do. Like, look at a list of problems and decide what to do for each. And don't do them yet, just decide and then go back and do them later. And this works really well if you've got worked solutions that you can't help looking at. Well, this is a good thing to do first. You can say, I'm going to decide what to do, and then I'm going to see what they did and see if it's the same thing. And then you can just read the first line of the solutions and go, oh, that was what I was going to do first. Awesome. And it gives you a bit of a boost without reading the whole thing. I would, in general, be better to do the whole problem before looking at the solutions. But this is, if you can't help yourself, then at least you can just read the first line and see if you did the same thing. Not to say that the thing that they chose to do first is the only way to do the problem. One of the issues with mathematics, for the purposes of studying, is that there are many ways to do most things. And so the official solutions is just one of the possible ways. And they'll pay marks out for anything that works, that is correct. So there are a couple of things that you can do wrongly and still get the right answer, and they don't want that. But most things have multiple ways to do them, and the people who mark the exams are good at that. They're good at telling if it's right. And it breaks up the monotony a bit for the marker, and so that they have a better life if yours is slightly different to other people's. But on the other hand, if yours just by chance happens to be the same as the exam solutions, it's much easier for them. Yeah, so I guess the overall rule is that if you can think of things that you need to be able to do in an exam, you have to practice those things. I just want to tell a little story that my first aid, one of the people who I learned first aid from told me. When you learn first aid and you learn how to use an EpiPen for anaphylactic shock, they give you a fake EpiPen and you practice jamming it into the person on next to you's leg. I mean, it doesn't have the needle, but whatever. They used to get you to practice jamming it into your own leg. But what would happen is that in the stressful situation when a person was dying on the floor from anaphylactic shock, people would get out the EpiPen and jam it into their own leg. Because your brain can't reason when you're under stress. And so your brain will let your body do whatever your body remembers doing when you're under stress. And so now they get you to practice jamming it into someone else's leg so that your body doesn't remember jamming it into your own. And it sounds funny, but it's true. Whatever it is that you practice when you're feeling safe is the thing that you will do when you're under stress. So practice doing things in a way, practice doing the exact things you will need to do in the exam. Don't think, oh, I'll do it sloppily now and then I'll do it fine in the exam. That is not how your body will work. Your brain and your body will do whatever it is you practice when you're in the exam. So if you practice not putting in all of the working that's needed, that's what you'll do. So Nicholas, the other Maths Learning Centre's lecturer, one of his favourite phrases is practice makes permanent. It doesn't make perfect, it just makes you perfect at whatever it is that you practiced. And that's not necessarily the thing you want. So if you really want to make sure you write every step, then you should always write every step. So the overall message. Practice the thing you want to be good at, basically. Because the thing that you practice is the thing you will do. Yeah. So not to say that you shouldn't ask for help, because obviously in an exam you can't ask for help. But while you're in the throes of studying for exams, practice trying it for yourself first. Practice giving yourself the grace and saying, you know what, I am clever, I can figure this out, before you ask for help. And when you're in the middle of asking someone at the Maths Learning Centre for help, every so often say to the person at the Maths Learning Centre, thank you, I'd like to do the rest my own, please. People who are helpful people, like the tutors at the Maths Learning Centre, will keep talking if you let them. And so at this time of year, it's really important to say to them, actually, do you mind if we just stop for a second? I need to think about what you said, or I need to do this myself for a bit. And know that we are moving around the room and we will get to you again. So if you don't have anything to say when we get to you, just go, it's all right, I'm okay. I just need to think about this a bit for myself more now, and they'll see you next time round. So don't worry that we won't get to you. We will, because if everyone's moved past telling us to move on, then we'll be fine. Yeah. So I hope that was useful so far. It's weird the things that you say aloud in these sessions that after you've said them, everyone goes, well, that's pretty obvious. But until you say them, they don't seem obvious. Yeah. So, yeah. Yeah. Cool. So if you have recognized it and you've realized to yourself that you've recognized something, you can stop at that point and say, just saying, I've recognized that. Now let me try and remember what it's connected to. So I'm just going to add to this. Also try to remember connections. Because the thing is that your brain, if you cross this path more often, your brain will strengthen that path. Like in a literal sense, like there's connections between your actual brain cells. Yeah, and paths that you don't cross very often, it will say, oh, I need some of that protoplasm elsewhere. Sorry, no, ectoplasm is the ghost thing. I need I need some of that protoplasm elsewhere. I'm going to move it, and so I'm not going to I need some of that sodium elsewhere, sodium and potassium elsewhere, and so it will literally make that a weaker connection because you don't use it as often. Not that it's doing any of this consciously. Like your brain is designed in such a way to work independently of your conscious thought a lot of the time, which just makes the entire thing extremely remarkable, really. Living things, and humans in particular, are just surprising. So anyway, but you can shortcut the way your brain works to say, well, I'm going to deliberately make these connections. Okay, so that's that. So some of this is really about how to make sense of things. So we're going to have to make connections as well. So that's the other thing. How do you try to make sense of things? Okay, so the thing is, for mathematics in particular, maths ought to make sense. So one of the problems with any learning of any discipline is that we try to force ourselves to learn it simply by remembering. Now, I've talked a lot about memory, and memory is really important, but it's the connections and understanding that makes you make sense of things. And it is the worst thing to have something that you think you can do, but you don't understand. That's a horrible feeling to have. And maths shouldn't feel that way. Now, sometimes it feels that way simply because there's just so much stuff in this course in particular that you feel like you don't have time to make sense of it. But if you don't make sense of it, you have a much lower chance of being able to, if all you want to do is remember, you have a much lower chance of doing that if you haven't made sense of it. So make sense of things. And what making sense of things means is connecting them together, but also knowing how the decisions are made. So making sense is like, know how things are connected. Have several ways of representing it. E.g. pictures, basically. Most people, even if they don't say they're visual learners, humans are mammals, and we've got no way around the fact that we do a lot of our learning with our eyes. But also, humans are mammals. We do a lot of learning with our bodies too. We forget that we live in a body and that our brain responds to where your body is, not just what you're looking at. And so sometimes it's not just pictures, but also movement that can help you represent things. Movement of hands, movement of your entire body, movement of your head. Cool. So know how things are connected, have several representations of things, and find out how the decisions are made. So I'm going to relate something, and I'm hoping you've had this feeling. You look at a written solution to something and you go, oh yeah, it makes sense. But then when you come to do a similar problem on your own, you go, how do I do that? And so it's the same problem of the recognizing thing. When you look at a written solution, you can say, yes, the solution itself makes sense. Internally, it's consistent, but I couldn't figure out how to produce that thing on my own. And that's a common feeling in not just maths, but many other situations, but maths in particular, especially with things that are about proofs. You can understand the proof that you've been given, but you couldn't come up with one because you don't know where the ideas came from, how they decided to do each step. And so the best question you can ask any maths teacher when they ask, do you have any questions, and you don't have a question ready for them, is to pick anything that they have just written and say, how did you decide to do that? If you can't think of a question to ask. And that has two things. One is it forces the teacher to think about how they decide to do that and makes them a better teacher. And two, you get the information that you need. So how did you decide is a really good question. And that's the one that you asked me before. How do you decide what to do first? Cool. And sometimes the way that decisions are made is because a later part of the working will be easier if you do it this way, and that's fine. And sometimes the decision is, oh, it just seemed like a good idea at the time and it worked, and that's okay too. And sometimes the decision is, oh, well, the meaning of this word is this, and so I just ran with the meaning of it. And these three things can help you make sense of things better. And the connections is really important. So, yeah. And the last thing about making sense of things is know how stuff is made. So there are some procedures in maths that are complicated and spent centuries people figuring out how to do them, and it's okay to not have to run through all of those centuries of research to understand them. But it is good to have an idea of how they were created, because it can help you feel better, either feel better about not really understanding or actually understand it better. So anyway, the big idea is that maths ought to make sense. Like, what mathematics is the logical thought about things that are logical. Not everything is logical in the world, and that's not what mathematics is for. Mathematics is not for understanding how human love works, because that's not logical. It's still awesome, but it's not logical. But maths is designed to be reasoning about things that can be reasoned about. And so if you are doing mathematics without reasoning, you are not doing mathematics. Yes. I just read some articles recently about some very horrible people who have spent decades trying to say that Aboriginal people didn't have mathematics. Don't get me started. But the point is that mathematics is logical thought about logical things, and the Aboriginal people before Europeans arrived did do that, because all humans do that. So just because they didn't write it down in the way that Europeans did doesn't mean it's not maths. But for this exam, you have to write it down in a way that the person reads it understands. But finding out how things were made, like, there was a way that it was made. Mathematics is reasoned out, and so there ought to be reasons. And so expect things to make sense. One of the worst things that happens when people study mathematics is that they give up on making sense because they don't feel like they have time, or they don't feel like they can. Well, you can, and you do have time, because you don't have time not to. At the very end, when there's a couple of days to go, there will be a couple of things where you're just going to go, I've got a general vague idea, and today I'm just going to do the thing that they told me to do. And that is the nature of the unnatural thing that an exam is. But overall, better to really understand it. Because if you feel like you have made sense of it, you feel comfortable with it, and you'll be okay just doing the thing without wondering about it because you've dealt with the wondering. You don't want to be in an exam and have an existential crisis about whether it means anything what you're doing. Better to deal with that earlier. I have heard of people having exam epiphanies, where in the middle of an exam question they suddenly go, oh, that's what vectors are. That's lovely, but it is a waste of time in an exam. You want to have those epiphanies earlier. Okay, cool. So yeah, maths should make sense. And so when you watch all the revision seminars, everything that I say is about trying to make sense of things and saying, well, actually, these things do have a sense. There is a reason why they are the way they are. And there's a reason we do them the way we do. Some of the reasons in maths are not logical because they're about human ways of doing things. So there's no particular reason why we have to write mathematics the way we do. It's just what's happened. And if we lived in a different universe, it would have been written differently. But once we've chosen the way the notation works, from that point forward, it will be logical. So I like to separate those things. And so why is it called this? It seemed like a good word. Why is it called sine? Because sine means curve. Which is weird because the sine doesn't measure the curve. So anyway, why is it called tan? Oh, because it literally is the length of the tangent. Oh, cool, that's nice. So some of them make sense, some of them make less sense, but it's good to know when they do and when they don't. So anyway, I'm just yabbering on. Feel free to stop me anymore. Okay. So this is a thing that you can do before your exam. Make sense of things. And this is great when you're in the middle of your study and you're not in the Maths Learning Centre, to write down, really want to ask someone about how these things are connected, or how this decision was made, or how these things are connected to each other. And sometimes we won't know how things are made and we'll look them up. But they're great questions to ask when you're with a teacher. You write them down and go, I really want to know this, and I can't tell from the way it's written. Yeah. So There you go. Cool, cool, cool. Right. So now I'm going to try and get to the how do you figure out what to do. And so now it's about problem solving. All right. So I'm just going to show you something. See the poster in the MLC. You may have not noticed it if you've been there, or you may have noticed it. I'm going to share something else now. This is the handout version of the thing in the MLC. It's the solving problems chart. It's not a flow chart, but it has "14 things you can say to yourself while solving problems to help you figure out what to do and help you to learn from the experience." So I'm just going to talk through it when my Zoom works. Here we go. So there are 6 pieces to it. The first one is to prepare yourself. Then you need to understand the problem. Then you need to decide what to do. Then you need to do it. And possibly you may, after doing something, go back and decide what to do again. And then at the end, when you're done, you need to look back. Well, possibly not at the end. Look back at what you've done. And then at the very end, you should reward yourself because you did it. And these are all important parts to the problem-solving process. Now, some of them can't happen during your exam, but it's good to know they're all there. So, the first one is to prepare yourself. So, you can do it is a great thing to tell yourself. There is nothing like thinking you can't do it to make it happen that you can't do it. If you decide at the beginning you're not going to be able to do it, you really won't. Now, deciding that you can doesn't necessarily mean it will work out today, but it's better than deciding you're not. But also, preparing yourself means doing all the study stuff so that when you come to the point of solving a problem in a situation where all you have is you better prepared. So that's that. Teaching your hand to be able to cope with the writing and having your calculator and enough pencils/pens that actually work and those sorts of things. Being prepared, like, having working pens and making sure they all work before you go to the exam is a good thing. Those sorts of things are really important because not having the thing you need today will slow you down and make it harder and make you freak out, and there's nothing like being under stress to stop you being able to think logically. And that's what you need if you're going to solve problems. So that's prepare yourself. You can do it, and you can do it because you're ready. Okay. The next step is to understand the problem. And the 3 pieces of advice we have under understand the problem are write or draw, it helps you to think, make sense of all the words and symbols, and look for other related information. So the problem itself, the written text of the problem itself, is where the first place you look for information. Every word that is there in that problem is there for a reason. And so when you make sense of the words and symbols, you have to make sense of what it's asking you to do and literally what the words mean. So if it says, as I said earlier, projection, you have to know what projection means in this context. If it has a symbol like a cross, you have to know, is that a multiplication or is it a cross product? What is that? And so a useful thing to do if you don't know what to do is to underline the terminology in the question and write down what that terminology means. Because at least you've, in your exam, shown that you know something, and so you might get a mark for it, but also you've reminded yourself that you know something. And once something is written down, then you have something you've written down that you can now say, I'm going to make sense of what I wrote. So if you're copying it from your cheat sheet, You write down, then you can look at, so if there's a definition of projection, you can write down what that means, and then you can look at that definition and say, well, what does that mean? And this, what does it mean, making sense of the words and symbols, is a really useful thing to do at any moment in any problem where you don't know what to do. Is to look at what's written then already and say, even if you just wrote it, and say, what does it mean? And some of the words will not just tell you maths terminology, some of it will be instruction words as well. There'll be words like verify. The word verify means check that it is true. Verity, like ver in that means truth. And verify means truthify. Like make this true. That's what verify means. And verify almost always means that you do not do the thing you would normally do to find the answer. It usually means sub it in. So if you verify that x equals 3 is a solution to x squared minus 6x plus 9, you'll sub in 3 and see if it turns out to be 0. Right, and so verify means that, whereas solve means do the things that goes from the equation to the answer. And prove means, show means provide logical steps, and prove means provide logical steps, and you must use the definition at least once. Right, that's, yeah. So you need to know what those command words mean. That's a lot just there. My goal is to have the back side of this handout to have some of this advice, but I haven't written that bit yet. So. All right, so that's the middle one. The first one says write or draw, it helps you think. Literally writing anything in the blank space will help you to feel like you're going to move forward. And so if the only thing you write down is the definition of the thing, then at least you've got something. If you don't feel like you want to write it in the blank space on the exam, you can write it on your scrap paper. They give you scrap paper. And so it can help you feel like you're moving forward. So that's good for how you feel, but it also means that then you've got something written on the page that you can then ask, what does it mean? And drawing is underrated. Always draw pictures. It has become tradition in mathematics to not have pictures in solutions to mathematics problems. And this is bad. Problems, drawing, turning things into a picture makes it easier for you to think about them. Yeah. So in the second year course, Real Analysis 2, which I just did a revision seminar for yesterday, they have to prove all sorts of things. And even though the proofs in Real Analysis are all text, they're all words and symbols, it is the drawing that tells you what to do. Yeah. So if you can't think of anything to do, then draw what the thing you've got is. Even if it's just blobs. It says this is the beginning and this is the end, an arrow between them. That's what I have to do. My last piece of advice to understand the problem is look for other related information. So once you've got your list of words that they mean, projection. I wonder, are there any theorems about projection? Let me go and look them up. Or, I wonder, is there any rules for how this symbol works? I'll go and look them up. Now, in the exam, you can't go and look them up. And so the only place to look for other related information when you're in the exam is inside your own brain, which means that before the exam, or your cheat sheet, right? Which means that you have to put things that interesting bits of information or useful bits of information about stuff in places you can find them. So you either put them on your cheat sheet or you put them in your brain by practicing remembering them. And I will say one thing, getting things out of your brain is the fastest way to get anything. If it's in your head already, reading it on your cheat sheet is slower than getting it out of your head. Because your brain is faster at making connections inside itself than looking for things. So if you've deliberately made connections so that every time, if you've practiced brainstorming things that are true about projection, then that'll happen in the exam naturally, or whatever it is, trig functions or whatever. So, yeah, but that related information, many exam problems are based entirely on you remembering a piece of trivia about your thing. It's like, oh, it's got sines and coses. I know a relationship between sine and cos. Yeah, a lot of them are based on that. So just what you said is, well, how did they know to like do a trig identity? It's like, well, it's a thing that they thought of. Yeah. So that's understanding the problem. And you can do all of this without actually getting very far, and you don't have to understand all the things before you continue. You only have to do this as long as you need to do before you decide what to do. Next step is to decide what to do. The problem-solving flowchart that this is based on by George Paglia back in the 70s has at this point formulate a plan. People don't formulate plans. They just make a decision of what to do next. So you don't have to decide the whole plan for everything. You just have to decide what to do now. So the first thing to deciding what to do is understanding what the goal is. So if they say verify, then you know what the goal is to sub it in and show that it comes out to the right answer. So you really need to look at which part of the question tells you what the goal is and understand what that goal means and how to tell if you're going to have reached it. That's an important thing to do. How do you know you're going to reach the goal? Yep. So notice that this is also about understanding the problem, but I put it here under decide what to do. It's actually a good idea to ignore the goal temporarily at the beginning when you try to understand the problem. So just say, well, what does it all mean? And then I will make a decision of what I'm supposed to do. Because once you've understood the context of the problem, the goal will make more sense. What happens when people look at the goal first is that they don't understand what the goal means because they haven't read the context of the problem. And so they've wasted a bit of time. Whereas if you read the problem, understood it, then when you read the goal, you go, oh, I know what that means. So those classic problem-solving questions, are they in Maths 1M where you have to maximize things, like you set up a function and you differentiate it and set it to 0? That's not in Maths 1M? Must be in Maths 1A. It was in high school though, right? Maybe. Who knows? So when you look at the goal, you can also say, the answer I'm supposed to produce, is it a number? Is it a formula? Is it a sentence? What am I supposed to actually write down here? So on the other end, choose a smaller part to try. Like sometimes if there's several pieces, focusing on all of them at once is a bad plan. Just do one thing at a time. And if you've decided to sub it in, don't worry about how that whole process is going to work. Just sub it in and write down the next line and then do what you can do on the next line and do what you can do on the next line and do what you can do on the next line. One of the powers of algebra is that it allows you to make decisions one line at a time about what to do. And that actually means that you don't have to worry about the whole process. You can just do one line at a time. And so choosing a smaller part to try is about that. But some of it is to say, oh, okay, this process that they've asked me to do, I know it's got 3 steps. I'm just going to do the first step. I'm not going to worry about the other steps until later. But sometimes you might choose to do the last step. Maybe there's no particular order. So that's fine too. Just pick something that's not the whole problem and just do a smaller bit. And in the middle, if you don't know what to do, sometimes you should look at other problems for inspiration. Now, if you're in an exam, the only place you can look for those is on your cheat sheet or in your own head. And so having tried to solve other problems can inspire you for new problems. So you can say, oh, this seems similar to that other one I did in the assignment. How did that one go again? What did I do there to get to the answer? Or I didn't get to the answer myself. What did the solutions do? It's not to copy what happened there, but to be inspired to try similar things. Sometimes it is to copy what happened there, but mostly other problems are inspiration for future problems. And I'm going to get back to this in a minute. How are we feeling about what I've been saying so far? All right, once you've decided what to do, then you do it. So my advice is focus on one part at a time. So you've already chosen a smaller part to try. Don't try and worry about the other bits while you're doing that bit, just do that bit. Once you've gotten to the end of that, then you can do the next thing. It's nothing like trying to think of two things at once. That means you can't think about either of them very well. The second thing is, even though you're focusing on one part at a time, regularly check with the goal. Don't keep the goal in mind the whole time. That's not productive. You shouldn't always be focusing on the goal constantly forever, because it will distract you from the things you're trying to do now. But every so often, every couple of lines, check in with the goal to see if you're getting closer to it, or to see if you're getting further from it. Sometimes you discover that the thing you're doing is actually a different problem than had been written down. And so it's good to check every minute or so, every 30 seconds or so, depending on how big the problem is, with the goal to see if you're getting closer. But don't think about the goal constantly, just check in with it. And if you look at the goal and go, oh crap ass, I'm getting further away, go back to deciding what to do and decide to do something else. It's okay to give up. Like, perseverance is a wonderful skill, a wonderful attribute to have, but you shouldn't be persevering with things that are making life worse. So decide every so often if the thing you're doing is making life worse, and sometimes give up and try something else. Yeah, sometimes it turns out you should go back to the thing that you gave up on and try that again. Just like when you're looking for things in your house and you've looked everywhere, and so you start back at the beginning and look in the places you've already looked. That's okay as well. And so the reason there's arrows both up and down on this chart is that once you're doing things, sometimes you have to go back and decide what to do again. And sometimes when you want to decide what to do, you have to go all the way back and decide if you understood the problem at all. Sometimes you have to go all the way back to the beginning and go, oh crap, I need to find a ruler. Yeah. And so there'll be this cycle of this thing. You'll decide one part to try and you'll do it, and then you'll decide the next part to try and you do that, and you'll decide the next part to try and you do that, and eventually you'll check with the goal and go, oh cool, I'm here. And here I am, and I'm at the end. And then there's one last thing to do. You have to look back at what you've done. So the first thing you have to do is be clear that you've actually reached the goal. Both for yourself, you have to say, have I reached the goal? Yes, good, I really am at the end. But also, when you read what you've written, can the person reading it tell that you've reached the goal? They said, find the maximum value of this. Have you actually written down the actual answer on your page in a place where they can find it? So that's an important thing to do. Make sure it's clear that you've reached the goal that they've asked you to reach. Nothing worse than solving all this stuff and then not writing down the actual answer. You need to rewrite it so other people can understand. In an exam, you might not be able to rewrite it, but sometimes you have a bit of time to go, oh crap, I just think I need to add an extra word there to make it even clearer. There's almost always something you can do to make it clearer what's going on, even if all it is underlining the answer. And then what you should do is find something you can learn. When we first wrote this chart back in 2011, this used to say, is there something you can learn? And the thing is, the answer to that question is always yes. So find something you can learn. It could be that you've learned something cool about how these ideas work. It could be that you've learned that, that you can turn one triggered entity into another. It could be that you've learned that you are capable of doing things. It doesn't really matter what it is, find something you can learn. Now in an exam, the find something you can learn maybe can wait till after the exam's done. But I will say, if your exam question has a part A, a part B, a part C, a part D, then you are almost always expected to learn something from the experience of doing part C to use in part D. Just pointing that out. So the finding something you can learn can be, what does this tell me about how the part D works? And the very last thing you need to do is reward yourself. And you know how at the beginning you said, I can do it? And then you look at it and you need to say, I did it. What happens is that people don't realize that they're good at problem solving because they never stop to notice that they're good at problem solving. There are people in the Maths Learning Centre who say constantly, I don't know how to do this. And then when I say to them, so what does this word mean? They go, oh, well, it means this. And then they finish the whole problem without me doing anything. And at the end, they still say, oh, but I'm not very good at this. You have to notice that you're good at things to feel better about it. But you also have to not discount things you did with help. Now, in an exam, you obviously don't have help. But, and therefore, it's the perfect time to notice that you did something yourself. But even if you have help, you still did things. You spent time making sense of what the person helping you was saying to you. That's still a thing that you did. Spend time noticing when you did things, because otherwise you'll believe you can't. And so this feeds again. If you do the rewarding yourself, then you get back to feeding into this and saying you can do it more often. But also, you should just reward yourself more often. So many people punish themselves for not doing it better. I go, oh crap, oh, I lost a minus. No. You found where you lost a minus and you fixed it. That's awesome. Stop punishing yourself for being wrong and start rewarding yourself for being right. Life is too short for punishing yourself. So anyway, that's one of my overall messages. The Maths Learning Centre is about trying to make you feel better about your mathematics as well as helping you understand it. So that is the problem-solving flowchart. And they are pieces of advice that you can say to yourself when you're in the middle of problem solving to help yourself to move forward when you're stuck. And also to learn something useful. I hope that is a useful thing to have showed you. A student that I used to have used to say to me when she was in the exam, she would imagine that she would say that I am her Jiminy Cricket. I'm her conscience from Pinocchio. And that when she's stuck, she would say, what would David say at this point? He'd say, what do the words mean? So, okay, what do the words mean? I'm happy to be your conscience if you want. Doesn't need to be me. But that's the thing you can say to yourself. What would the problem-solving chart tell me to do at this time? It would tell me to look at other problems for inspiration. Oh, cool, I did write some examples on the cheat sheet. Now, a lot of people say you shouldn't put examples on the cheat sheet. Ignore all advice about cheat sheets, really, other than it has to be something that you personally can use. It has to be the thing that when you ask yourself for advice about what to do when you're in a problem, it has the advice you need. So if you're the sort of person who will be inspired by looking at a problem, it's fine to put existing problems on there. If you're the sort of person who'll be freaked out by having to read a problem during the exam, don't do that. Your cheat sheet is yours. It is your thing that you has to be useful for you. But in general, it has to contain the things that you would normally get from outside yourself when you're solving problems, such as other related information and other problems for inspiration. Cool. Yeah. Advice if you don't have cheat sheets is to still organize your notes. If you can imagine what your notes are like, because you've put it in a format that is easy for you to think about, then you can do it even if you don't have a cheat sheet. You really should make your cheat sheet in such a way that you could be okay if you lost your cheat sheet on the way to the exam, and you could remember what the cheat sheet was like. Yeah. One of the major things a cheat sheet does is be a souvenir from your study time. Probably would do the same, have the same effect if you had a teddy bear that always sat with you when you studied and you took it with you, because you could look at it and it could remind you about things that you thought when you were studying. So the cheat sheet, if you make it as you go along, it can remind you of what you were thinking at the time. Yeah. So I'm not sold on cheat sheets. Sometimes I think they create more stress for people than it needs to be. Don't spend too much time worrying about your cheat sheet. It's there to help you. Don't turn it into a cross to bear. Yeah. Cool. If you've spent some good amount of time making sense of the content, you'll be okay. And the cheat sheet's just there just in case. just in case you can't remember things because the stress impedes your memory. Just in case you need somewhere to look to feel inspired. Oh, just one last thing. Look at other problems for inspiration. Those problems could be the rest of the exam. Sometimes if you're not inspired with what to do, you should skip to the next problem and it will just randomly remind you of math stuff you did this year. And plus, you know, part A will inspire you for part B. They write exams that way. Not always. Sometimes they're just, oh, this section is about differential equations and each of them is a whole different thing. That, whatever. The Maths 1A exam usually has a question that's about integration and they're not related. They're just there. The worst thing is trying to find out how they're connected, but they're not. Yeah, usually if they put them together into one problem, they are related. Yeah, so there you go. That was my advice for studying and exams and problem solving. It's probably enough. Thoughts or questions?
That's just absolutely mad that you said that was off your head. Like, you give me, I would prepare something, and that was, especially that first part with the handwritten about how to remember, that was really, really useful. So I 100% think that chucking that on the other maths ones as well
Cool.
would be super useful.
I'm going to stop that one.